So, hi, Purti. How are you?
Hi, I'm good. How are you?
I'm good. So, we will start the session in just 5 minutes. So, everyone will join. Then, after we start.
Sure, okay.
So, can you introduce yourself? Like, from where are you and which discipline you are?
Um, so all of these days, I have actually been attending your session as the YouTube video. So I have not attended because I didn't get the time to join at this particular timing. But through YouTube videos, I was watching all of your videos, and it was extremely helpful actually. If I may say, even more than the actual course YouTube videos, your information and the kind of questions and problem solving session that happens, I find it very, very useful. And accordingly, I've given the feedback also. So I am Purti Savardekar. I'm from Goa College of Engineering, from Goa University. I am a faculty and I teach subjects which are related to signal processing. So I'm from electronics and telecommunication background. So my
Okay.
subjects are signals and systems, digital signal processing, digital image processing, artificial neural networks, soft computing, and now remote sensing. So I'm studying that from you for my research.
Sure. Thank you.
Thank you.
So, what's our plan for today is first we'll see some of the MCQs from the previous year assignment for week 7. And then after now onwards, we will start learning one software which is known as QGIS, which is open source GIS software, which you will be introduced in this course as well after 2-3 weeks. So what we are going to learn in that particular software is uh, basically how to play with geospatial data sets. So geospatial, when we talk about geospatial data, so in that case, like anything which have coordinate information associated with it, the data is known as a geospatial data. So there will be like two types of geospatial data which you will find like where one is a vector form and one is in raster form. Raster is like continuous in terms of image or matrix we say, and vector it means it's like kind of discrete data sets. So we will more learn about those things while doing hands-on experience. And if time permits, we will also see one of the remote sensing like a web platform, let's say Google Earth Engine, in which we can process the remote sensing data sets as well. So first we'll start with QGIS. We'll also learn satellite remote like image processing in that as well. But then after if we have time, we'll go through Google Earth Engine as well. So with this, we'll start today's session. Let me share my screen. So are you able to see my screen?
Yes, yes.
Yeah. So hello everyone. My name is Hiren Solanki. I am a PhD scholar in the discipline of Earth Science at IIT Gandhinagar, and will be taking this problem solving sessions of the course Advanced Geomatics Engineering every Monday 7 to 9 p.m. You can join if you are interested. If you in meanwhile if you lost the connection, you can join using the same link. So first of all, we will learn about some of the basics of LiDAR, and then whatever you have gone through this video lecture. So we'll not go into that, but in a nutshell, if I want to say, then is like light detection and ranging. So one light beam will go and it will come back, and then whatever time it took to travel, we will calculate the distance from it, like using the simple velocity formula as we did in GPS as well. So there will be like two pseudo ranges we will find. We'll just use the formula of like velocity is equal to distance by time. We already know the time and velocity we'll find. And then based on that, we'll find the distance, how much distance it traveled. So that is a basic phenomena of this radar. So there will be like a few questions based on this week 7. So we'll just go through it. So first two questions was on like GPS applications. So the first question is a station is. So can anyone tell the answer if they know? Exactly. So total station with integrated GPS module. So if we look at the how this instruments evolved over time, earlier we used to use chain and tap to for the surveying purposes. Then after theodolite came, then level came, then auto level, digital level. Then we had total stations, and then now whatever the total station you have that are like integrated with GPS module, or okay, you can say that our robotic total stations are also available in market. So those like good thing with this is we can improve our survey accuracy to the like millimeter level as well. And we can like if something is not visible while doing the survey, we can get the tentative coordinates as well through GPS module attached with it. So that's like how the evolution took place of those all those stations. And like when GPS is inbuilt with the total station, it is considered as a smart station. And there is another word also that is robotic total station. So robotic total station in that GPS module is not there, but all the facilities or all the working you are doing that are like that are like controllable through the just one person. So you do not need two-person, and you can control those instrument robotically as you can so, like do other car like toys, and you just have joystick kind of thing that through that you can just like take the readings. So that is robotic total station, but here the word is smart station is there, which is like when you integrate GPS module with total station. Then there is another question that there is a GPS application in this field. So when we talk about GPS, it's like we can use it for any application under the sky. So there will be no doubt it can be useful for all the applications. But that the main thing is like we can use it for every application under the sky. If something is there below ground, so it might not be useful because we will not get the signals there from the satellites. So here the answer will be all of this. Then the third one is the accuracy of LiDAR devices ranges from, so we know that LiDAR is very highly, like, so accuracy will be high, but at which level? Can anyone remember from the lecture slides?
0.25 to 1 mm.
Okay. Anyone else? So it's like basically 0.75 to 3 mm. So then we have terrestrial laser scanning. So basically when we take a laser, we have three different models. One is terrestrial, which means the like sensors we have mounted, scanning lasers can be mounted on the like land. So that's why it is known as a terrestrial laser scanner. The second one will mobile. So in terrestrial, it is like constant. We fix the instrument at one location and we are doing the scanning. But if we have not fixed the instrument, but instead of it, if it is moving throughout the survey, then it is known as a mobile laser scanning. And the third will be like if we are taking the data from the sky, so then it will be known as a airborne laser scanning. So first, when we talk about terrestrial laser scanning, so which of the statement is particularly true about it?
Second and fourth.
So the
Second and
first
fourth,
one is,
yeah.
yeah. So the first and second, first is like ground based, so that is true. Then the second one is can acquire the millimeter level accuracy, so that we already seen in the previous question. So that is also true. And then we can measure the three-dimensional space. That is also true. And here the word satellite based is not true. Why? Because here we are using active sensor. That sensor is like sending the laser beam or the, and then it is coming back. So it is not based on satellite, but it is having their own active sensor inbuilt in the laser scanner. So that's why the third option is incorrect. Now, when we talk about mobile laser scanning, which of the following is true? So the first one is true, a vehicle based because it's like moving. Or, so that's why mobile means moving. So the first one is correct. Then it's capture the imagery which is georeferenced during the data processing. So that is not partially true. Like it's not true. It captures the imagery which is georeferenced during the data process. So no, it is not georeferenced during the data processing. It is already georeferenced because modules, GPS modules are there sometimes are associated with this, and then takes more field time than the terrestrial laser scanner. As you know that it is a mobile, so we'll need less time. It will not take more time to do the survey. So the third one is also incorrect. And the fourth one, that system can be used for surveying and mapping in inaccessible areas. So that is true. Then the mobile mapping system maps larger area of terrain while equipment is movable. So here the thing is, it can be useful for the larger area of terrain. So that is true. And equipment should be movable in that area. So that's true. So if our equipment is movable throughout the survey site, then we can cover the larger area. So that's why it's true. Then the next one is LiDAR system is composed of which particular units. So it's like it contains all of the above. So control unit, it has ranging unit, IMU, it means the like inertial measurement units, which are having like which is already there in all the type of aviation systems, and then GPS for the accurate mapping of or georeferencing purpose. And then we have aerial lidar creates a data with a height accuracy of so we'll just look it out. It's just numerical information that you have to keep in mind. So it's plus or minus 10 centimeter. Then which of the term is not term used for drones?
One.
Exactly. So all the three you can relate with drones. The first one is like not relatable. Then which technology provides better resolution of photographs? Exactly. So
UAV.
UAV or unmanned aerial vehicles or the drones will provide the better resolution of photographs. So now with that said, this topic is not that much useful for gates and other exams, so we'll not go into that, and we'll just start looking at the software side. Before that, I will show you one of the YouTube channel, which is like which is a land surveyor in the US based land surveyor. So you just search this name Rami Tamimi. He's a surveyor, and he posts different videos
This is
on like
exactly how I went from
different kinds of survey using total station, robotic total station, GPS, then drones. So he gave like a review all kinds of instruments which are available in the market, and he also compares the some of the sensors which are available in the our mobile as well. So in one of his video, what he did is he took the total station, which is like a surveying instrument, which also gives the millimeter level accuracy, and he took the another hand the iPhone's lidar scanner. So iPhone also have their lidar scanner, which is useful to measure the different objects. So then he compared the accuracy between the iPhone lidar scanner and the actual surveying instruments. So if you are interested in learning those different instruments, how to operate that, and like how to what are the like currently available instruments which are there for surveying and purposes. So you can see like high accuracy indoor survey mapping. So we'll just one of the video. It's just in brief. We will see. Uh, so just give a sec. So what he do is like in some of the iPhones we have this applications through which you can generate this kind of 3D stuff through yours by scanning through your mobile phone. So I mean, if you are interested more in that, so you can is how he's doing the particular scanning using the different thing, and once it is done, how to process the data, and then how to make a 3D model out of it. So you can just look out it if you are interested. So that's it. So you can just go through those sites. So now we will start with the learning the software, which is known as QGIS. But Before that, like I just want to ask you guys that have you installed the QGIS and downloaded the data which I have asked you to download? If not, then I can give you some time. Meanwhile, I can discuss something else. If yes, then we can directly start the session.
For me, QGIS is installed, but I think the files
Data
that you
sets.
are expecting.
Okay, so what you can do is you can just go to, I think my screen is visible to you, all of you. So I will just share it one more time. So you can go to the discussion session of this course, Q&A session. In QA session, you will find that I have given two links, one to install the QGIS and one to install the dataset. So this dataset, if you download, I have prepared one manual which I teach here at IIT Gandhinagar. So in this, if you just click, it will open a OneDrive link and the data folder. So you can click over here, download this file to your device, and it will download this data folder. So if someone wants to do hands-on along with us, so they can download this thing, and meanwhile I will show that what kind of information it has.
Can I interrupt you for 1 minute?
Yeah, sure.
Um, would it be possible for you to share the OneDrive link here on the chat window? Because
Yeah,
Google Groups is not allowed by my organization, meaning I can't
sure.
access other organizations. Sorry, thank you. Thank you so much.
So basically, in this, like we have prepared 7 to 8 modules on QGIS, and then if you go through this manual folder, there is a one manual which is given there, so which contains the in-depth like exercise what we are going to do here, and which we have done at IIT Gandhinagar. So I will be like teaching the same thing over here. So that you will get a good exposure over the QGIS. So because like I found this suggestions in the previous year's same course that you should teach one software. So that's why I'm focusing more on this. So here one exercise is there on Google Earth Pro, but this is like very simple. You can just go through it and you can just learn it how to use it. So we'll start with the second module, which is based on like QGIS and map making. So once you download this QGIS, if you have Windows, you can just use this link. For Mac, you can use this link, and the training data is also there for QGIS side. So if you are interested more in it, you can download their own training data sets as well. And once you download it, it will show you the QGIS window. So we'll look into that, and at the end of every module, you have some case studies, so you can try to answer that along with your assignments, regular assignments, so that you will learn more about it. So when we go through these data folders, it will be like day two QGIS. So there will be basically two folders will be there: assignment and tutorial. So assignment is like something which you have to do by your own self, and tutorial means the folder which we are going to cover. And then you can make your own folders over here, whatever the results you generate, make it in new folder, or whatever the data you generate during this exercise, you can generate a temporary folder into that same folder, and whatever you do, just save everything there only, because otherwise when you work with any kind of GIS softwares, it will generate multiple files. So better to save all the files in a particular folder rather than saving it on desktop or a downloads folder, or somewhere like where it will be like trouble for you to remove it from one folder to another. So basically, just create a temp folder in whatever the day's exercise we are working on, and whatever the answer you got or the data you processing, save the results into temporary folder of that particular day or that particular exercise. So with that, we will start. Meanwhile, like, do you need more time to download the data sets? Anyone else?
I think you could continue with your demonstration because my dataset downloading is showing 1 hour because I think probably
Okay.
the meet is also going on, so download speed is less.
Okay. That's
But I
fine.
will try to follow your steps.
Yeah. What about others? Do you want to do the hands-on or you will do it after using the YouTube videos? So according to that, I will adjust my video. Yes.
Continue with the next career.
Can you write in chat the link of the YouTube video? So I think all of you are very new about this particular GIS softwares. So first of all, what we will do is I will show you some of the basics slides based on this. What do you mean by QGIS and what is in general GIS is? And then once we are like done with that, we'll go with the start with the QGIS. So meanwhile, if you are downloading the data, it will be also completed. So we'll just look into very brief that what is GIS and what kind of things you can do into it. And then after we will move to the QGIS software. So basically when you talk about GIS, it is a geographical information system and it's a geographical. It means it has power to like create, manage, analyze different kinds of geospatial data. And geospatial data, it means the data which are having latitude and longitude information along with it. So here you can see some of the data sets that one terrain is there and how something is changing along the terrain. And then you can convert the data into different kinds of information and then you can use it for the decision making purposes. So whenever we talk about GIS, it's a spatial system that creates, manages, analyzes, and maps all type of geospatial data in nutshell. So basically, our main aim over here is to prepare maps. So prepare how to visualize geospatial informations using maps and how to prepare those maps in such a way that it can be helpful in the decision making purposes. So that's what we are going to learn from this particular software, or you can say GIS. So when we talk about GIS, like when we have this what we want to do is we just want to visualize the geography in terms of maps. So here we have one small map of Austin, and then we just zoom that map, and then we have the zoomed version of it, where we have focused on some particular stretch of the particular city. And then once we zoomed more, then we also see different kinds of buildings, roads, and locations, and so on and so forth. So what you can see here is we are using visualizing maps. And in maps, if you see, we have different components that it has line, it has this polygons, it has this location. So we have some different kinds of things so that we will see further. So when we want to work with GIS or like when we want to see like how does this GIS works. So first thing is it has maps, two-dimensional geospatial information or three-dimensional geospatial information. So maps are geographic container that has data layers, or you can say data layers. It might be a remote sensing data or the data which you collected through surveying or data which you collected through the manual survey. So it can represent anything. And maps are like a basic foundation of this GIS. And how to prepare those maps? So using the data sets. So GIS integrates many different kinds of data layers. So it might be a layer of water, layer representing vegetation, layer representing building. So we have multiple data layers. Sometimes it can also give some information about the financial parameters as well. So the financial income of the people, or how much they spend. So this kind of information will be useful when we work with some of the company who wants to establish their firm in such an area, which will give them more profit. So we need geospatial data for that. And then the next step will be is like how what kind of maps. So when we talk about maps, so maps are built from the data sets. And what kind of data it will be having? So we have the building data sets, we have the road data sets, we have river data sets, we have canal data sets, so on and so forth. Whatever you want to analyze, you can just convert that into geospatial data sets. And here the thing is, it has different shapes, which is like known as a vector. So when we talk about any maps, so it will be like two types of map. If you see on the Google Maps as well, so I will just show you that thing that if we go to the maps. So in Google Maps, we have this kind of image, and we have this different maps which are available. So when you see this kind of map, it is vector map. Why vector map? So let's say I will zoom to the IIT Gandhinagar location. So what we can see over here is we can see the different line segments which is representing roads, different polygons which are representing buildings, which are present in the campus, or you can see the different sport grounds which are available in the campus. And that's way like how you can visualize the different things using this polygon, point, or this kind of lines. And point it means you can see different amounts of like construction sites or the petrol pumps or the like bank details, so that you different temples, so that you can represent as a point data. And when we talk about this lines, so lines can be useful for road network. Then we can see for this river also we can represent it as a line. Then we see one canal is passing from here, so that also we can represent as a line because it's a linear feature. And when we have parks or forest or something like this, that we can represent as a polygon feature. So different things we have to present using the three types of data, which is the basic foundation, which is known as a vector data sets. So that is point, line, and polygon. So point, it means it has latitude and longitude, just location information. Then line is having the sequence of points. So different points. Just give me a sec. So then we have different lines. So lines is nothing but it is a made up from different points. And then we have this like a point we have, so there we have line segments and the nodes connecting those lines. So that is known as nodes or points connecting those lines, which is known as node or vertex. So this is the starting and ending point, and these are meanwhile in between vertexes. So line has a extra thing along with the coordinate. It has the length parameter as well. So how long that line is. Apart from that, when we talk about polygons, so it is a combination of line and point. So we have the latitude and longitude. Then lines is also there. So we have just let long information, perimeter, and then area, which is made by this closed geometry of that polygon. So here we have three different features: xy, then perimeter, and then area. So when we talk about this point, we have just xy, line, xy, and length of the road, and here xy, perimeter, and area. So four things it can represent. So here you can see how lines, points, and polygons can be useful for a map. And then once we want to convert that into raster data sets, so raster it means what? Now if you see, if you put your Google Maps image like this in a satellite view mode, so if you see here, there is different views. So if I put on this satellite view, then it will show me like this. So it will show me basically image which is captured through the satellite. And what it is showing over here, it is continuous in nature. So it's having different pixels. If you zoom, you can see the small pixels over here, which represents the as we learned in the remote sensing, it represents the DN value or the digital number, which reflects the brightness value. And based on that, we can identify which feature it is. So this particular data set is known as a raster, where our data is continuous in nature. So if we want to convert our point data into raster data, this point will look as a one pixel. Line will look like this, and this polygon will look like this. So this is termed as a raster data. So basically when we talk about GIS, we have this two data sets. One is a raster and one is a vector. And we are going to work along with this two data sets. So then you have this kind of data for different layers. So here you have the land use data, rainfall data, elevation data, so on and so forth. So basically we have different types of data. Now if I ask you a question that which of the following layer is a vector layer? So what will be your answer?
Think the first three streams: hydrographic, drainage, channels, maybe
Exactly. So those
hydrography
looks
also.
like, and this hydrography also is looks like as
Mhm.
polygons are there. So it is also apart from that, if you see surface terrain in this
Rain.
rainfall response, those looks similar to raster data set, digital or so this is like differentiation, and we have to combine all those data sets and we will make the decision out of it. So this is the way how we can integrate those different data. So this is a raster data, this is a vector data sets, and then once we integrate all of them, it will look something like this. So like this, we will do the analysis, overlay everything on top of it. So basically, we will put this kind of building data sets, vegetation data sets, and then we will integrate and make a model out of it. And then once we have data sets and maps, we can analyze those maps and the data which we developed, and we can take a decision out of it. So here you can see I have collected the different data of land cover, soil, slope, distance from stream, distance from roads, and I can classify my site for any particular application, that whether the site is suitable for the construction or not. So I have the different criteria. If it follows that criteria, I will give the score and I will find out which is the site which is more suitable for the construction purposes and which sites are not suitable for the construction purposes. So then we can take the decision out of those maps. And then we can, if we have those data sets, we can put it into one kind of application, which we also learned in few labs before, that Bhuvan portal we saw that has having so many GIS data sets in it. So we can make some application like this. So when we talk about applications, it should be like timely, accurate. It should provide good information. It should disseminate the knowledge. Then it should communicate the importance, that how like importance. What is the importance of, like when you talk about the reserve forest or the biological sensitive areas or the wildlife or basically habitats. Then it should show the status, that if we are having any kind of construction project or any scheme is going on, like Pradhan Mantri Gram Sadak Yojana. So how much construction has done till now, and in which area they are working right now. So it should show a status of the projects. Along with it, it should help us in the decision making, which is our ultimate aim. And it should illustrate change what happened before and then what is happening now. So we can take decisions according to it. So basically, and then after, if we know what happened in past, what is happening in right now present, and then we can predict the future using the future data sets, and we can find out which are the zones which are under risk due to the landslide, due to the floods, due to the earthquake or any natural disasters. So basically, it should ultimately it should tell a effective story out of the product which you have developed, and that we are going to do this in GIS. So with this small introduction of this thing, particular GIS, I will start learning the QGIS. So first of all, you just write QGIS into your search bar, and you can open this QGIS desktop 3.16.9 version. If you have some other version, that is also fine. So it will take time according to your system. Meanwhile, can anyone has any experience working with any GIS software till now?
Oh, yes, I have worked with the QGIS before.
QGIS, okay. So have you done any basic analysis, moderate or advanced level stuff?
I wouldn't say advanced. Um, I have worked with it for certain kind of mapping,
Okay,
which was related to land surveys only. Department of the Land Survey here in Goa wanted certain things, so I'd work with them.
okay, sure. Anyone else has any experience with the GIS? Okay, so we'll just wait for some time. It will take some time in opening up. So it's open now. So when you open QGIS, it will pop up this kind of screen. So you can just click on new empty project and it will show you something like this. And don't worry if it does not show you something like this. So these panels are movable. You can put those panels according to your like ease or how you like. So whenever you have any difficulty in viewing the different things, that here first we'll see what kind of layers panels are there. So here you can see the processing toolbox which has different kinds of tools. Here we have browser panel through which we can go through different data sets, different folders, and we can open the data sets. Here the layer panel where it will show the whatever the layers which we are adding in QGIS that will be shown over here. Then these are the toolbars. So if you are not able to see anything over here, let's say my processing toolbox is not visible. You have by mistakenly you have just click on this close button. If it is not visible to you, what you can do is you can just first you have to think what you want to do, because no do not need learn this software as like learning, just see what you want to do. So right now it is not visible to me, it's not viewable basically. So I will go to the view option, and then view option, if you will explore, you can see here the at the below bottom you see panels and toolbars are there. So I can go to these panels because those were the different panels, and then I can go to this processing toolbox and I will just click on it. So it will add that processing toolbox. So if any of the layer is not or panel is not visible to you, you can go to this view option. You can go to this panels and you can add those whatever you want to edit over here. Just click on it, whether it is a layer panel or processing toolbox panel or the browser panel. So all those things you can edit over here. Similarly, if some tools which is available on at the top, if you are not able to see those tools, you can add those tools using this toolbar as well. So different digitizing tool, different plugins, different raster, different vector. So all those things you can edit from that view and toolbar. So if something is missing, you can edit using this view button. Then this first one is a project, which is useful to create a new project or to if you have already made some project, so you can open your own projects over here also. And then you have to just if you want to like this as it is similar to different softwares, you have the save button, close button, exit button, layouts button. So this will be like new print layouts, new reports that will be useful for preparation of maps that we will see in this particular video only at the end once we upload every data sets over here. Then we have edit, so it is like to edit any of the features if you have added anything, if you want to edit out, so you can use that edit. Layer, it means whatever layer you are adding over here. If you want to make a, if you first of all you want to create a new layer, if you want to add any particular layer, or if you want to duplicate any layer, if you want to save layer, export any layer, so that all those things you can do it from here. Settings, you can go to user profiles and you can create your own profiles over here as well. So it's just to keep in mind that I'm working, not the other person. So if more than some people, like one people is using, so that you can create the profiles and you can put the settings on. The style manager, it means to which for visualization purposes. We will look into it after some time. And this projections, it's for like maps, data, and coordinate systems that we will also see in just a few minutes. These plugins are the different small tools which is developed by the different users. So if we go to plugins and manage and install plugins, it will show us the different plugins which are available within the QGIS or outside the QGIS. So this will be like small tools which is like automated the different thing, or it will be it can integrate us this QGIS with the some of the website which has already data into it, or you can do different types of task utilities from those different plugins. So here, I mean, if you want to download any plugin, so let's say I want to add up different base maps. So for that you can have different plugins. So this is two good plugins that HCM GIS. So what you can do is like you can just go to this plugin, manage and install plugins, and you can write whatever the plugin you want to add. Let's say I want to add this HCM GIS plugin. So I will click onto it and I will click on install. So it will start installing that plugin into my system. And once it is done, it will show me that plugin installed successfully. And then you just close it and you have this HCM GIS. So here, if you go to base map over here, so it has different maps which are available automatically. So if I click on Google satellites, it will open the map of Google satellite. Similarly, if I go to Google Maps, it will open a Google Maps. If you zoom, it will just zoom it along with it. So you can do like this. Apart from that, you can see satellite hybrid map is there. Terrain map is also available. So you can see the different terrain patches over here. So similarly, you have different maps. You can just import each and every, and you can see how those maps are different with each other. So right now, we'll not go into that. You can just like find out using by yourself. Just add and just check. Apart from that, if you want to add different maps, you have some other plugins as well. So we have one more plugin known as Quick Map Services that is also useful for different base maps. Then this map tiler is also there, which is a street and satellite base maps for using vector tiles. So that is also there. This Planet Explorer is also there. So this different plugins are there. You can install the plugins and then you can work on it. So that's all about plugins. Then when we have vector data and raster data, so these are some of the tools which are applicable when we are working with vector data, and these are some of the tools which are available when we work with the raster data sets. Then after, if we are working with a different big amount of data, we can use this database manager. Then we have this website tools, so which has some other tools in which we can also use. Then this is for mesh data. This is for processing. So this is processing toolbox. Then if you want to automate something, we can use this graphical modeler. Then history, whatever the tools you have executed before that you can find out from here, and the results viewer. If it is giving some error or bug, then you can find out what that error means using this results viewer. And then whatever the extra plugins that you are adding, according to that, it will show you the different tools. And then at the end, you have help, and you can go to about. So you can, if you go to about, you can see which QGIS version you have, what is Python associated with it, GDAL library, and then other versions which is available, OS and all those things which is there. So you can just, this is all about the tools, browser panel, layer panel, processing toolbox, and QGIS windows in nutshell. And those tools which you see over here, they have their own utilities. And so that we will learn as we learn through this map, if we just go through this class. Over here at the bottom, you have something also that if you want to locate something, so if you want to see any find tool, or if you want to search anything, you can write it down over here in the search panel. Apart from that, you have this over here, the coordinates. So this coordinates will show you the latitude and longitude of any place whenever you move your cursor. Then this is showing the scale of the image which you are seeing right now. You can change that scale to 1 is to 50,000, 1 is to 2 like to 50,000 according to that as well. And then after you have magnifier to zoom in or zoom out purposes. Then if you want to rotate your map, you can do that as well. And then at the end, you have the coordinate system. So this coordinate system is like any kind of reference system where you, which will show you that how you will put your X and Y data sets. So you will look into it. It's basically there are two different kinds of coordinate systems which are available. Which one is a geographic coordinate system, and the second one is a projected coordinate system. In projected coordinate systems, the units of measurements are in meter, where in geographic coordinate system, units of measurements are in degrees. So if I select this EPSG 4326 WGS 84, and if I will click on OK, it is a geographic coordinate system. So now you can see units I can see in degrees. So 72 degree east and 22 degree north. and I can see accordingly. So this depends on which coordinate system you are using. So according to their unit system, you will see the coordinates over here, whether it is in meter or degree. So with that, it's like a basic layout of QGIS is done. Any problem or if you have laptop in front of you, just go through it. If you have any doubts, just I will give you 3-4 minutes. Just look into different panels, how you can add the different panels if it is missing, how you can install the different plugins. So try to install the plugin which is like HCM GIS. So we'll give you 2-3 minutes. After that, we'll start our next.
So we will be needing this base map now.
No,
Should I?
not right now. But it is like whenever you start working with any GIS operation, first you need to know which location you are working on. So if you have base map, it is good. So if you do not have any base map right now, what you can do is you can go to plugin,
No,
manage
I
and
installed
install plugin.
HCM. I installed it, HCM. Which one should I
Okay,
open? Which base map should I
that's
open?
fine. That's fine. Once you open it, you can try with any one of it. Isri, Major, you or anything. You can right now you can just put any map, base map. So go through the layout of QGIS. If you are not getting anything, like what is the purpose of any other tool or something, if you are wondering why, and in between just try to ask questions. If my space is fast, just slow me down wherever required.
I think you can go ahead. Mine is open.
Okay.
Yeah.
Okay. So what we can do now is we can start working with the data sets. So for that, I will click on this new project and we will create a new project. So I don't want to save this current project, so I will just discard it. So create a new project first of all. Now we want to add data sets into it. So for that, what we can do is we will go to this open data source manager. So on toolbar, you have this three kind of red, yellow and blue squares are there. You can
Yeah.
click onto that open data source manager. It will open up this kind of window. So over here, you can see you can browse any data sets. If you have vector data, you can just select the data from the folder which you have and you can put that data in raster data, mesh data, delimited text data, geo package. So these are the different data types that QGIS you can add it into QGIS. It supports basically. And in browser, it means you can add any general data sets. So under browser, you can see different folders are there, or you can see this browser panel only. So what we can do is, let's say my data is stored somewhere in the D drive. Let's say my data is stored in the D drive, PhD, and then this training, then this GIS, and then data. So my data is there in this particular folder, which is like very inside the drive. So it's a D drive, PhD, training data, then the GIS summer school, then data, and then I have all the data. So what you can do is you can just directly right click on the folder which has all your data and you can add that as a favorite. So add as a favorite. So then after once you add that as a favorite, it will go up and it will add that particular folder into your favorites bar. So now I have all my data sets located into this only particular folder.
Done. Done. Okay.
Okay, so first of all, add the folder, whatever you have, and favorites. And try to put your folder in the sub drive. Basically, do not put in the downloads or do not put into the main drives. Try because it will populate so many data sets, and if it is on your main drive, it will become problem in handling your system, or your system might get slow. So what I'm talking about is when you have opened this PC, This first drive is your main drive, and then this is the subsequent drive. So you can put your data sets into the subsequent drive, what you have, or that's it. So which will not slow down your system. If it is the first one is full where your system is installed, then it will make a difficult thing.
Yeah, my structure is like yours only, similar.
Okay, so that's it. So first we will add our folder into favorites, and this will be like a good way to do it, and we will follow it throughout this particular training. Now today we are going to start with this QGIS. So you can go to this day 2 QGIS, and then we have this tutorial folder where we have different subfolders that's such as catchment, DEM, river, salt pen, shapefile, and two CSV files are as well. So we'll click on this catchment and we will open this w1.shp and then w2.shp. So you can just double click onto it and it will open that data into QGIS window.
Yeah, done.
So now can anyone tell me this is which kind of data first of all?
Polygon
Raster
file.
or vector?
Oh, vector file, polygon.
Vector file. And in vector also it is a which data? Line, point or polygon?
Polygon, polygon.
It's a polygon data set. And then if I ask you the question that which location this data is representing. So this data is taken from which area of the world? If I ask you that, what will be your answer?
I will open the attribute table to check it.
You can just check.
No.
So how to open attribute table, those who don't know, we will right click on a layer and we will go to this open attribute table. So it will show you the different attributes which this data has. So in that, nothing is mentioned.
Yeah,
So if
nothing is
I
there.
want to see that which location this data refers, so what I can do?
Base map I left
Exactly.
open.
Exactly. So I will add base map. So I will go to the any plugin, let's say CMGIS base maps, and I will add the let's say right now we'll go with the Google satellites maps only. So we will see the
It's in Gujarat, I think.
so this data is in Gujarat, or
I
preferably
think
you can see
Gandhinagar.
it's in the Gulf
Yeah.
around Gulf of Khamba. Oh yeah, Gulf Cambay. Okay, so these are the rivers which are draining into the Gulf. So these are the like catchments
Okay.
of those rivers.
Okay, okay.
Okay, so this is like how you can identify your data. Now, when you talk work with the data, let's say I don't like this green color or I just don't want like this violet color. So if you want to change the colors of the data, what you can do is you can right click on a layer, you can go to property. So I want to change its property basically. And here different properties are there. So the first property is information, which will give you the idea about in which coordinate system your data is, what is the units of the measurement. So here you can see the units is in degree. Then further information if it is has, then what is the source of your data sets. Then this third one is symbology. Symbology, it means how you want to visualize your data. So here you can see it's a simple field and I have selected this green color. It has selected green color automatically. So if I want to select something there, I can click on this simple fill and I can just, what I did is I clicked on this simple fill button. Instead of this, inside this, I clicked on simple fill. Now here I can change the fill color to something else. And if I don't want to keep any color, then I will click on transparent fill. It means it will not keep any color, it will just keep the borders. So this fields color and fill style. Fill style means you want to keep solid color, if you want to keep horizontal line, vertical line, dashed line, if you want to keep. And this stroke color, it means the outline color. So outline color is black and this width of outline is 0.26. Instead of 0.26, I will click 0.66 or zero point 0.5. And then if you click on apply and OK, then you can see now it does not have inside color. It just have the color at the boundary. So we will do the same thing with the second layer. We will remove the inside color and we will just increase the borders. So it will look like this. And similarly, you can change it to any different colors, whatever you want. So if there is a need to repeat, just let me know. I will repeat this stuff.
Nah, done.
Okay. So then after, what we will do is we'll see the different properties as well. So if you click on properties, then we have the fourth property, which is label. So if you have any attributes in this particular data set, the name of this watershed, so you can put that as a label over here. You can put the mask around the label and so on and so forth. Now this different uh, like properties which you can see that we will learn as we go through this course. So basically you need to learn about the symbology and labels as of now. Now we will add the other data sets. So I will further click on this data source manager and I will go to this QGIS folder. And now instead of this first folder catchment, I will go to this DM and I will add the first study area DM field.tif and then I will just close it. So what do you see here? Which kind of data it is? Raster or vector?
Raster data.
It's a raster data. Why? Because you can see this data is continuous in nature compared to the earlier data, which is discrete. So earlier one was, uh, you can see different discrete boundaries are there over here. Whereas
Yeah.
the data which we added right now, it's a raster data and you can see the pixels also over here. So raster data is made up of different pixels. And if you want to measure the size of these pixels, we have this measure tool over here in the toolbar, measure line. Over here in the toolbar, third row, we have this measure line button, which looks like a scale. You can click on that and you can measure something. So you can see now whatever the one pixel is representing the size of around 30 meter, around 30 meter it is representing. So that you can see, so one pixel is 30 by 30 meter pixel. So 30 by 30 meter area on land is shown by one pixel. And you can see this particular thing that how the raster image will look like. And then if I see this, it is going from this black color to white color, shades of gray. So what does that represent? So here it represents the third dimension. So when we talk about this image, X and Y will be having this latitude and longitude information. And the data which is there inside the pixel, it will represent any variable. So over here it is representing digital
Hello.
elevation model, which is
Uh,
the basically elevation. Yes.
I didn't see how you converted to black and white, that grayscale.
So I didn't do anything. It's just as it is only what I opened.
Okay, I got some different colors. Okay.
Okay. So is it like totally different or
No, as meaning it is showing elevation, so it is scaled, but it is colorful, not grayscale.
you might have changed the symbology?
No, I didn't.
Okay. So in that sense, let me check your thing. Can you share your screen if possible? Yeah. Okay. So can you just remove this layer first of all and then add that layer one more time? First one. Yeah. Exactly. Okay. So you might be seeing as a different color. So if you want to put it as a black and white, you can just go right click on that layer and then go to symbology, properties, right click, properties and symbology. Yeah. Here you can see it has already given the data set as a paletted values. So it depends on your QGIS version. It has already given the values. If you have selected black and white, it will show the black and white. And if you just click there one more time for symbology, So what option is right now on in my screen is just cancel this. Instead of paletted unique values, the first render type, go and select the single band gray, the third option. Yeah, and then just click on apply. Okay, so this kind of options you can see here, single band pseudo color. So there you can select different colors. So you can see color ramp is there. So you can just write, you can select the different colors and then just apply and okay. Yes, that's what we are going to see right now. Just stop sharing. So that's how we can change the colors of the raster layer. So it might be in your QGIS, it has automatically given colors to the layers while we imported the data. So what we can do is we can right click, we can go to properties, we can go to symbology, and instead of earlier one, my color was single band gray and black to white or white to black you can select. But instead of it, like I can go and select single band pseudo color. And here you can see this is the minimum and maximum elevation of your data sets or minimum or maximum value of your data. Then after you have color ramp, also what kind of color you want to show. So right now I will select the spectrum. But as you know that this is the elevation data. So how one should represent it as if the value is lower, reverse will be there. So I want to see if value is less, I want to see blue color. If it is high, it should show red color. So I just want to invert this color. So for that, what I will do, I will click on this particular triangle, and in the first option is invert color ramp. It means it will invert the ramp. So I will click on that and I will just click on apply. So now you can see this is the low lying area, which is blue in color, and this upper portion is like red and yellow. And then further, if we want to fine tune these colors, we can adjust the minimum and maximum value. So what is the problem here is blue color is much. It means we can change this minimum range over here. Instead of 60, if we just write 40 or 10 or 0, so it will change. Similarly, if we can change this maximum range, so it will show like this. So you can adjust this minimum and maximum value, and based on that, it will change it. So basically, you can select such range which will like make your maps good or visually appealing. So this is like how I selected right now. If I want to reduce this blue color more, I can change this back to instead of -60, I will just go to -80. Okay. So like this, you can create a maps. Then further, if you have different layers, you can arrange this layer that I want to keep this DM at the bottom and other two on top. So you can keep those two layers on top. So it will look like this, that on top you have your two vector layer and at the bottom you have your DM layer, which is representing elevation. So this is
Yeah, that.
about raster and vector data. Any question till now?
The when I'm selecting colors, no, the basic value of digital elevation does not change. No, obviously, it is just assigning colors to whatever existing values. Okay.
Okay, can you show your screen?
No, there is nothing wrong.
Okay, nothing wrong. It's fine.
Nothing
It is
wrong.
just
I'm.
interpolating. So what it is doing, it is interpolating in between. So see, there is different visualizations will be there in QGIS. So here, like it is continuous in nature. So if it is see, blue color is given to -80, this green color is given it to -10, and whatever value in between it will come, it will interpolate for in between values. But instead
Correct.
of it, if I will select here the option paletted and unique values. So what this particular option will do is it will assign the unique values to unique IDs. That if elevation is 60, assign green color. If elevation is 61, assign dark green color. If elevation is 63, so with every value, the color will change. And we will be
Yeah,
having
got it.
different classifications. See here, if you see, for every value you have different colors. And if you apply this one, it will look like this. But we want to see continuous data. So if it is changing, we want to interpolate in between as well. So for that, you can use single band pseudo color, which we used earlier. I will just change the invert the color ramp.
I'm sorry, how did you invert the color map?
You can click on this color ramp only, and then first option is invert color.
Oh, okay, thank you, thank you.
Okay. So now we will add some other layers as well. So I will click on open data source manager, and then I will go to reverse. So the third folder is reverse, and then I will add the data sets of reverse. So it will add the reverse. Similarly, I will add the next data set, which is salt pan. So I will add those November 8, November 17 salt pan. And so this much data I will add till now. So now you can see this river data set is which kind of data?
River is line and the other one is polygon.
Polygon. Okay. So line, like if I want to put my reverse as a dark blue color, I will do the same thing. I will go to right click, properties. I will go to symbology, and I will change the color to dark blue color. So it will change the color of river to dark blue. So that's it if you just want to do it with like this. So now you can see how the rivers are flowing from high elevation to low elevation. And then in this low-lying area, some salt pans are there. So the salt pans are nothing but it is the salt producing units. If you want to visualize that thing, you can uncheck the other layers and you can open your Google Map image. So you can just uncheck the other layers by taking it. So it will just hide it or just remove it for a while. And then if you want that layer one more time, just click on it. So you can see now if we put on the reverse layer and the salt pan layers. So this what the people who are living near this coastline they do. They extract the salt water from the surrounding area because sea is nearby. So they have ample amount of salt water. They put that salt water into this particular big ponds which is known as the salt pans, and then it will produce the salt as the water will evaporate from that particular pan. It will generate the salt out of it, and the salt pan which you are seeing over here is Asia's largest salt pan, which is situated in the Bhavnagar district, which is owned by the Nirma company. So now,
Oh,
I mean that you can observe the different small salt pans also that how this salt will look like basically. And so basically water, and they will put this water into this particular like pans, and then it will like water will evaporate, and then it will salts will be there. And that data we have digitized for 2008 and 2017, which you are seeing right now. So this data is from two different years. One is the salt pans which were there in 2008 and then salt pans which were there in 2017. So if you see in 2017, some of the new salt pans came in the vicinity. So is this fine? So this kind of change analysis you can do with the data.
yes.
Yeah, so we are going to solve one case study, and these are the part of this case study. So the first thing is we have rivers, and the second thing is this salt pans and how they evolved during the time of 10 years. Then we will add one more data sets, few more data sets. So we'll add the data sets such as Blakebuck National Park. So this one national park is situated over here. So that data we will add. Then we will add the data sets related to the roads, data sets related to the nearby villages. So we'll add these three data sets. So one is
Roads UTM also?
no normal roads. So one road is in degree, one road is in meter. So normal roads you can add. And now you can see, we'll just put the other layers on so that we can visualize it properly. So roads color is not visible properly. So we will change that color to something which is visible more. So we'll select the black color with some more width. So this is road, these are roads. And then this one is a black buck sanctuary. And then villages we can represent with something else. So villages now you can see it's a point data sets. And point data sets you can represent it as a different symbols, the diamond, the circle, or like if you airport, medical center, campsite. So you can show it something like that. So right now I will select something like this, white color and inside that black color dot. So those are villages. And now in the starting we talked about the attribute table. So what kind of attributes we can add it into the village file. So we can right click and go to this open attribute table. So here what it has is, it has its ID, the name of that village, then X and Y coordinate. Along with it, we can also add the different attributes. Attributes, it's having any characteristics that data has. So attribute means we can have the amount of population which is there in village, number of men's, number of women's, number of childs, number of hospitals, number of schools, number of high schools, number of buildings, or how many, what is the financial capability of that village. So that kind of parameters we can add over here for every villages. What is the area of that village? Okay, so that kind of things we can add it as an attribute. Now, if you want to visualize that attribute as a labels, so for that, what we can do is we can right click and go to properties and we can click on labels. Here in labels, we have single labels, and then after selecting single labels, you can select any ID which you want to represent. So I want to represent the name of village. So I have selected name there and I will click on apply and OK. So you can see the different name of different villages came over here on your maps as a label. You can change the font size, font color if it is not visible to you. So those things you can do it later on. Okay, so till now what we learned is we learned to add raster data and vector data. In vector data, we have added the line data, point data, and polygon data. So whatever the layers which we are seeing right now, this watershed layer W1, W2 are the polygon layer. This salt pan layer for 2008 and 2017 is also polygon layer. Then this village is point layer. Then this Blakebuck National Park is the polygon layer. Then these roads and rivers are the vector layer, which is representing lines. And then this elevation is raster layer. So we have added the two types of data, GIS data, vector data and raster data. In vector, we had line, point, and polygon. And here we have raster data, which is continuous data. Any doubt till now?
No,
Do you need more time to do it in your systems or should I continue?
I think you can continue.
Okay. So now what we will see is that we will add some other data sets. Let's say I have CSV file. So how to add the CSV file into QGIS? So first of all, you have to create a CSV file. So let's say I want to see basically in the data which I have with me right now.
There are two CSV files in the data
Yes.
that you shared.
So what we are going to do is we are going to add the CSV file having the name of death location. But before that, I will show you how to prepare those CSV files. So here in this CSV file, what I'm having is, so I'm having this ID, location, and XY coordinates. So ID is necessary like to differentiate your data uniquely. Then the location name, and then we have this latitude and longitude. So whenever you prepare any GIS data, it should have latitude and longitude column in it. So that's why your data is geospatial data. Otherwise, it's a kind of normal data only. So once you allocate latitude and longitude information, then your data will become geospatial data sets. Now, if I ask you that, in Vijayawada, floods is happening right now. Like flood happened a lot. So what we want to do is we want to see what are the villages which got affected due to the floods in Vijayawada. So we will open these news articles, different news articles, and we will go to each and every article, and we will see that which location it mentioned. That if it is mentioned that so location XYZ, that flood happened at that particular location. So we will note down that location into our CSV file, and then after we will also extract the latitude and longitude from the Google Maps. So like that we will prepare our CSV files. So here the CSV file which is given to you, so that is representing death location and death of what, that we will see later on. But now if I want to, so what I did is I collected the news articles and I found it the geotech those locations, so basically latitude and longitude, and I created that CSV file. Now if you want to open that CSV file, how you can edit over here is, you can go to this browser, or you can see over here delimited text option is there. So delimited text, you can go to delimited text. Over here you can click on this three dots, it means browse, and you can browse your file wherever it is. So what I will do is I will click on that location and I will click on open. Now this is CSV file, so it is automatically detected the file format. Then we have to define its geometry, that which attributes gives the location information. So if your data file has having the name such as x, y, latitude, longitude, lat, long, it will automatically extract those fields as x and y. And you have to give the coordinate system. So whenever your data is in degree, you have to use this EPSG 4326 WGS 84 every time when your data is in degree. And then you can click on add. So once you click on add, it will add that data sets into your QGIS window. And it's a depth location, so we will change its symbology and we will show it with the something red color, red diamond, let's say. So now we will focus on this particular area as of now. We'll just, okay. So now we have all the layers with us.
Yeah, yes.
Okay. So what this death location means is, it is the death location of a black box. So here you can see this black box sanctuary is there, and this is the death location, is the location of the death, black bug. So from where the Forest Survey of India or the this department recovered the dead body of that particular black box. So now we want to see that why that death is happening for black bug. So what is the reason for that? And for that, this data which I have given to you, that is important. So what is happening over the year is, first of all, we will focus on this particular Blackbuck National Park. So first, if we see that this park is having the grass fields around it. So you can see it has having the grass land basically. So basically, this is having the grassland, and within this Blackbuck National Park, you can see different rivers, which is a source of water for the animals which are or blackbucks which are living there. And then you can see here the different sports which they have created for the watering purpose. And then we can also see one of the highway is also passing through this particular Blackbuck National Sanctuary between from this particular highway. And around this sanctuary also, like a national park also, you can see some of the highways is there. So which shows the different locations of different villages. And if you are visiting Gujarat and if you are visiting this, you can go through this particular site, national park, through this particular locations where this is the entry point, and you can go further and you can be in this particular camp. So all this is like the grasslands where the black buck lives. So what is happening in the time is that due to urbanization and the villages are constructing there and the roads are coming over there as a development, and the major development which is happening in this area is this salt pans, which you are seeing is the salt production business which is there along the coastline of the Gujarat. And you see this Gujarat is the number one in producing the salt in the India. And you can see there is a subtle increase in the salt pans. And when you see the salt pans, so over here, and when this national park is there, you can see the construction of the salt pans in the last 10 years. So if we see this is the like 2008 salt pans, which is with the yellow color. And then if we click with the 2017, so there are so many salt pans that came up in this particular area. And what this salt pans is doing is they are blocking the ways of rivers.
Oh, okay.
So you can see it is they are blocking the way of waters. And if we put something where the water is flowing, what will happen?
They won't have a source of water.
No. What will happen if water is flowing and if we put something obstruction there, what will happen? That water will accumulate there. It will create a situation like dams.
Huh. Okay.
Okay, so water will be accumulated behind this particular spot where they are having this salt pans. And because of that, what is happening is that this area, which you can see, it's actually a low-lying area. So there is a high chance of the flood inundation or flood will like water will be there 1 or 2 meter depth. And because of this construction activity of the salt pans, the water accumulation is very high. And now due to which the water will like this area will get flooded because of the water. And for that, what black bucks will do, they will go to this some area which is at higher elevation. So if we put the DM layer, then you can see this particular area is like low lying area only. If we want to go towards the high elevation area, we have to either we can go towards the upside, which is in the north direction, or towards this particular direction. Okay, so this is like little bit up direction. We have to zoom it more and we have to see the elevation more in detail over here in this area. So we can find the slopes and then we can see this particular area which you see in this southern direction. It is a area at higher elevation, and this area on the northern side, you can see this area is at higher elevation, but so many villages are there. So blackbuck will not prefer to go into that direction. So instead of it, it will go towards the southward direction where the amount of population living is less and area is having high elevation. So what is happening that when they are going towards the southern direction, they have to swim through the water, which is
Flood.
accumulated because of this salt pan, and they have to swim. And once they reach near to the higher location, their energy is drained out totally. And what will happen when they will reach towards this kind of villages, stray dogs will be there, and that stray dog will make a hunt for those black bugs. They will make them as a food. So they will hunt the black bugs, the stray dogs which are available in this particular area. And that's why you can see the death locations are there in this particular southern direction. When the black buck is trying to go to swim from this particular location, which is actually Blackbuck National Park, through which they will swim through this particular area and they will reach into this higher elevation area, which you can see here as you are going in a downward direction, the elevation is increasing. And while doing so, they will drain their energy, and dogs will hunt them. So that's why we can see the death locations in this particular areas. So this is if you have the data sets, you can make a story out of it. You can find out the region, what is happening, and you can take a decision out of it. So when I worked on this particular project, at that time around 2019 or so, so this topic was very in a news and article and all. So then after what they did is they created the high elevation mounds in this particular area, so that whenever now rain will come, black bugs will go towards those mounds rather than going towards the village. So they have created the mounds of soils which are having 8 to 10 meter high elevation. So now whenever rain will come and flood water will be there, black bugs will go there instead of going there. And now they are also coming up with the new highways around this particular area, which is connecting the hubs like Ahmedabad and Bhavnagar and the rest of the Gujarat. So they have considered the little highway elevation little bit up to make the natural flow of the river rather than blocking it. So earlier construction was blocking the natural ways, waterways, but now whatever the highway they considered that thing and they created the highway at a bit upper elevation. So that kind of decisions or the you can take out of learning out of this kind of studies. So what you can do is you can search different news articles and you can see the what kind of applications or the problem is there in your area and how you can solve those problems using the geospatial data. So first target is identify problem. Then after you have to see what kind of data will be relevant for this application. That which raster data, which vector data is necessary for solving the problem. And once you know that it can be solvable, download every data sets, collect all the data sets. If it is not available, generate it using the CSV file from newspaper article or some books or forest area report or the wildlife report. And then after once you have all the compiled all the data, put that into GIS layer and try to see the region out of it. Along with it, now what thing is missing over here is you can also put the satellite layer which shows the flood inundation, that how the water got accumulated during the rainfall during this particular time 2019 or 20, and what is the scenario right now. So is this still happening after the construction what they did, or now this problem is resolved. So you can see those things also afterward. So like this you can solve problems. So you can see different kinds of case studies like this. So we will see different kinds of similar case studies in each and every lab session or each and every basically topics which you have. So now that's it for this how to add different data into QGIS. Now when we want to present this to someone like someone who is in higher authority, we cannot present our data like this. So we have to prepare a map out of it. So if I want to prepare a map of this particular region, how to prepare a proper good map out of it, this data which I have. So that thing we will learn now. But before that, let's have a 5 minute break, and then after we will start this map making process.
We can
Before
adjust the
that, yeah,
transparency also, no? The
yes,
transparency of a layer.
yes. So if you want to change the transparency, so that option, if it is raster data, you can right click, go to property, and there is option of transparency. So you can reduce the transparency from 100 to whatever you want. If it is vector data, you can click on that any particular layer. Let's say salt pan 17s. Then you can here the option opacity is there. So instead of 100, you can make it to 60 degree or some 60% or something. So it will become opaque like this. So you can also change that as well.
Okay, got it. Thank you. Thank you.
Yeah. So before that, if anyone else has questions, you can ask. Otherwise, we will take a break of 5 minutes till 8:35, and we will start afterward. You what? पानी अपने હાલ से ચાલુ રાખવાનો. હું કરવા હું બનાવું સ્ટીફનમાં હું બધા ના હતા કે રહ્યા ગયા So I think we can start now the next part of mapping. So for that, we'll go to our QGIS window one more time. And now we want to prepare a maps out of it. So first of all, we'll go to this project and we will go to this new print layout.
You're not sharing your screen.
Oh, okay. Sorry for that. Is it visible now?
Yes, yes.
Yeah, okay. So we'll go to project and then we'll go to new print layout. And then we will write it as a map 1. So you can give any name to your map. Now, in map, when we see any map, we have 4 to 5 map elements which are there. So we have north arrow, legends, then scale, title, and then data which we are representing in grid line. So these 5 things should be there on map. every time when we represent. So first thing we'll put the data. So to put the data into map, we can click on this button, add map. So on the left hand side, you have different tools where you have this tool which is known as a add map. I will click on that and I will select the area in which I want to create my map. And I will draw that particular box. So it will show me the data which is already there on my QGIS window right now. Okay, now first thing what I want to show is that we want to show the this two catchment and the rivers which are there in catchment. So we will like turn off different other layers which are there. So what I just want to keep is this two catchment digital elevation model and then rivers which are there in the. So we just want to show this much thing first. So whenever you do something, you can just click on this refresh button and it will refresh the screen. But if you don't want to see like change whatever you have done, if you want to lock your layer, it should not change what you with what you are changing in your QGIS window. Then you can click on lock layer. So basically, it will lock the layer. And now, if you do anything over here, let's say I will put my Google satellite mode on. Then also it will I will do the refresh. It will not change over here. But as soon as I will remove this lock layer, it will add that particular screen. So basically, if you don't want those kind of changes, you can uh, click on lock layer button. Once
I'm
you are
sorry,
done,
I cannot see where you're clicking for lock layer. Where is it?
so it's in the right hand side
Hmm.
over here. So if you have clicked this map button or if it is selected, map whatever the data you have added, if that is already selected, if it is not selected, you can click on this map one on the right hand side. Then you have this item property and
So,
then
yes.
that layer lock layer.
Mm-hmm.
So basically it will lock your layer. Lock your layer means whatever is there on QGIS screen, now it will not change anything afterward. It will show whatever is there on QGIS. Now you can see here, I can see the half catchment only. I am not able to see the entire data sets. So basically what I have to do is I have to scroll it and I have to zoom it a bit further. So if you want to move your data around in the panel which you have added, so for that you can click on this button, which is tool, which is like move your data on left hand side, the fourth option. This
Yes,
scrollable
got it,
option
got
is
it.
there, move item content. And then
Mm-hmm.
you can you can drag your data, you can zoom in or zoom out your data like this. If zoom in and zoom it is too further, like if I'm doing zoom in, it is going like this. If zoom out, it is going like this. So you can set the manual scale over here also under this item property. So you can change the scale over here as well. So instead of 31, I has done 36. And then after you can move it a bit further. So according to that, you will adjust your data. Once your data adjustment is done, we are good to go with adding other items. So I will just click on this mouse arrow so that now it will not move the data panel. And now I don't want to add anything else in my layer. So I will lock it. That's it. Now I will add the other parameters. So first of all, when we see map, we have north arrow. So to add north arrow on menu bar, you have add item. In add item, you can add north arrow. So you can click on north arrow and just drag and drop and it will add the north arrow like this. Then we can add a scale bar. So add item, add scale bar, and you can add scale bar. You can select the scale bar wherever you want to keep. Okay, so you can keep the scale bar. Then if you want to add border, out of your outside your particular map. Then you can just go down, you can select that map and go down, and over here you can click on frame, so it will add frame. Once you have framed that, you will get more idea that how to move your layers and all. Okay, so now north hero is there, scale bar is there. Then we have to add title, so add item, and we will add title. So title means different text. So we will add text over here. So you can add label. So this is known as a watershed. So once you add this add label button, you can write over here. You cannot edit over here. You have to change over here in the item property. So I will just write watershed map. Here you can change the font. Instead of 10, you can make it 14. You can make it change the color. You can put it in center, top, alignment. You can adjust. You can make it like bold, italic, whatever you want. So you can just go to the configure format and then just make it bold. If you want to change the font style, you can also do that. So yeah, so I have the title as well. Now what else I have to add is legend. So add item, and I will go to add legend, and I will draw a box. So now in add legend, when I will do, it will add different legends. So whatever is available on QGIS window, it will add everything here. But I don't want each and everything. So for that, what I can do is I can go to this item property, which is there on right hand side. Over here, there is an option called as auto update. So it will auto update the layers which are there. So we will uncheck that option. So it will do the auto update off. Now, what we want to keep it over here, we want to remove the satellite image because it is not there. Then death location is also not there. Study area, river is not there. Roads are also not there. Blackbuck National Park is not there. Village is not there. Salt pans are also not there. So we will remove it. And then this black line is representing watershed. So we can keep either one. So we have just two data sets. One is raster, one is vector. And this W1, if you want to change the name from W1 to watershed boundary, you can double click on it and you can adjust the label. So I will write watershed boundary, and that's it. So I will keep it over here, and then you can see here this white box is coming. So if I want to remove this white color box also, which is background color, I can go down and I will just remove the background color. If I want to add title as a legend, so I can go up and add the legend, and then you can change the font size and everything, like clicking on fonts and text formatting. Then this raster also, this is representing elevation, so we will also change the name of that. So we will write elevation, which is in meter. So in bracket we will write meter. But here you can see this elevation is like discrete in nature. So blue is minus 80, this light blue is minus 3. So it should not be like this. It should be continuous in nature. Okay. So to add continuous bar, generally in some system it will show as a continuous data. In some of the version it will show as this box values. So if you want to add continuous data, and if it is showing like this, what you can do is first you can remove these elevations from here, and in legends we will just keep this watershed boundary. Now we can add one text label named as elevation, because we want to show the elevation which is in meter. Okay, and we will change the font size according to the font size which we have for the other text. So I've added this text particular. Now I want to add that particular bar, which is showing this particular color. So it will be like rectangular. So I will add the rectangular shape. So here you can see different shapes are there. Or else you can go to add item and there also this add shapes is there. So I will add the rectangle and I will draw a rectangle like this. Now the color of this rectangle is white, but I want to make it similar to what I have over here. So for that, what I will do is I will go to the property of that rectangle and over here under style property, I will select configure symbol. It means I want to change the property of that rectangle. Now instead of simple field, I will select the gradient field because these colors are like gradient or the color ramp. So I will select the gradient field and then instead of two color, I will select the color ramp and I will select the color ramp which I used for my data layer, which is spectral color. So it will show me like this.
Hold on. I lost you at gradient field. Could you go back?
Okay, yeah, sure. So
Mm-hmm.
first of all, you have added the rectangle. So I will add it over here, something like this.
Yeah, yeah.
Now I want to change the color of this rectangle to the color which I am seeing over here.
Yeah, I
So
went to
basically I want to
simple field.
change color. So
Hmm,
I
hmm,
go to style
hmm.
and configure symbol.
Yes, yes.
Okay.
Hmm,
Over here, instead of simple, as you
hmm,
can see, is a gradient. So I
hmm.
will select the, instead of simple, I will select the gradient. Okay. Now
Oh, oh, okay, okay, got it. Hmm, hmm,
in
hmm,
gradient field, either you can use two color or either you can use color ramp. So we
hmm.
will use color ramp.
Color ramp. Okay, okay. Hmm,
So
hmm,
as if you click on this color ramp, it will show a color ramp. And then
hmm,
with this drop down, we will select the color ramp which we want.
hmm, hmm, hmm,
We want the spectral color. So I have added
hmm.
that.
Yeah.
Okay.
Okay.
Okay. Now what else we have to edit? Now we have added the color bar, but we have to also show the minimum and maximum value of that colors as well. So we'll go to our QGIS screen and we will go to this property of this EM symbology and we will see the minimum and maximum value. Minimum value is -80 and maximum
Hmm.
value is 230. So we will note down that -80 and 230 and we will
Hmm.
add the text label for it.
That's right. Hmm.
So in the top it is 230 meter and bottom it is -80,
But
-60.
I had changed my symbology, meaning I had changed the numbers. I had put the numbers from 0 to 245.
So
Yeah,
then you
245.
can write 0 to 245. So what you can
But
do
then the
is
colors are different.
no,
Hmm.
what you can do is you can always go to the your data layer, open the symbology of your data layer and whatever you are showing over here, minimum and maximum value, the color
Hmm.
bar is representing that only. So the minimum -80 is represented by blue and maximum 230 is representing by 230 by red color. And
Red.
whatever
Hmm.
numbers in between are there, it will interpolate using the scale. So what here minimum and maximum is, it is defining this outer values, which is -80 and 230. If you, in your case, if it is 0 to 250, it will be like
240.
0 over here, 250 over. But you have to note down the value from over here, -80 to 230.
Yeah, so then if I write those values here next to the
Yes.
rectangle that we have created, my actual color ramp in the image is not uh, that shade.
No, so it is in that shade only, but
Actually, sir, in this image showing the highest and lowest
Yeah.
in this
exactly,
particular lizard,
exactly. So
or
what
there,
you
in this
do,
reason there are
what you
no showing this classification according to 4 or 5 classes. This is not a
exactly. So
yes.
what we can do is here see. First of all, you have to see this higher, red is higher value, so you can write 230 at the top and negative value at the bottom.
Mm,
That is first point.
mm,
Okay, so
mm,
here I will write -80. That is the first point.
mm,
Now the second thing which you are getting is that in my image I'm not having this red color, but still I am showing that on my color.
Yeah.
Okay, so it means that this is the higher value. What
Yes.
we are representing over here, it means if it is this shade of color, we will see where this shade is there in this color. So if this color is there, we will see that shade in this color. And we will interpolate between those 230 to 80, minus 80. And you can add more also, but in general, this color maps will give you the tentative idea that whether how it is changing from high elevation to low elevation. If you want to add more, you can always do that thing like whatever it had earlier as a box. But in general, if you see any maps, it will be just for the tentative idea.
Okay.
So we just have to show minimum and maximum value. If this maximum value is not there, it means we have to interpret in such a way that our data is starting from that range. We have not utilized this minimum and maximum range. And sometimes we can set our range in such a way there in this symbology only over here only, so that it has every color. But if it is not there, do not worry about it. That's fine.
Okay.
So
Yeah.
is this fine till now?
Yes.
So now we just have to add a last thing, which is the grid lines. So on maps, you see it will be written as 80° north or 23°, 80 degrees to 23° north or something like that. So if you want to add those grid lines, how to add that? So first for that, you have to select the map which you have prepared. So your data layer, which is a map 1. Then you go down item property.
Yeah.
And then go to grids.
Yeah.
Then click on this plus button and click on this grid 1 and click on modified grid. Now here it will ask you the type of grid, which is solid. And this CRS, it is a coordinate reference system. So every time when we need different maps, you will see the data sets in degree only, the 23° north, 84° east. So we will select something which is in degree only every time. So we will select this 4326 every time. Every time when you have, like, if you want to put your data in degree only, you have this 4326.
Yes. Okay.
And then we have to specify the interval of X and Y. So we will see in our data set, if I am going from one point to another point, how my X and Y value are changing. So if you see here in the bottom, if I am at the extreme left hand side, it is like 71.2 degree. And if I am going towards this right hand side direction, it is going towards 72.2. So it is having around the difference of 1 degree. So what I can put is over here 0.1 degree. That's it. So I will see the different lines at every 0.1 degree.
Okay.
Similarly, I will add the line at every 0.1 degree at Y direction.
Okay. Got it.
Okay. Now here you can see the solid lines is there, but it doesn't look good.
Yeah.
So if you want to remove the solid, you can make the cross also. If you don't want to cross, you can put the markers as well. And if you don't want to keep anything, you can just keep the frame and annotation. Annotation means you will have the values. What is the value that we will add now? Now to add that value, first of all, what kind of frame you want to add? So do you want to keep this kind of zebra frame, then interior ticks or exterior ticks or interior and exterior ticks? So you can select accordingly what kind of ticks you want. Once the frame is fixed, you can go down and you can click on draw coordinates. So once you click on draw coordinates, it will show the actual value. And now you can see here it's just showing 72, 23. So if you want to add suffix such as north or south, you can click change the format. So here instead of decimal, you can write the decimal with suffix. So it will add the suffix such as north or east along with the data. And now you can see here, if you zoom it, you can see it's a 71.8. So after that, after point, 3 digits are there. But we are not interested in the 3 digits. We are just interested in after point 1 digit. So what we can change is, we can change the precision. So if you go scroll your screen, you can see there is a option of coordinate precision. So instead of 3, you can make it to 1. And if you want to increase the font, you can increase the font instead of 10, 12, like this.
I lost. I didn't get your ticks part. I
Okay,
was doing something else.
okay,
Frame
okay.
style
I'll
ticks.
let
Got
you
it. Got
know.
it. Got it. Got it. Interior or exterior? Exterior ticks.
Yes.
Okay. Got it.
So the
Got it.
first option is you have to put your interval. Once the
Hmm.
interval is fixed, you can remove the solid line.
Hmm.
Because solid line is there, then you can visualize that how many points it will show. Once
Hmm.
you know that how many lines it will show, just remove the solid line and put the frames and annotations. Then go
Hmm.
down and select the frame size, so frame type. So there you select interior or exterior, and then go down and click on draw coordinates. And then under draw coordinates, you select the degree, decimal degree with suffix. So it will add this north and east. And you can
Hmm.
change the coordinates from 3, precision from 3 to 1. So
Yeah.
like this, your entire map will be there. You
Yeah.
can change if something is not looking good, you can change it to some more place. And with this, you can do. Now, if you want to add something else,
Hmm.
that along with this map, you want to add some other maps as well. That's the
Hmm.
location map where this location is there, or the maps of salt pan or something else. So you
Hmm.
can select this add map option and you can just draw that map over here. So it will add another
Exactly.
map.
Okay.
So
Hold
that,
on.
yeah,
Could you tell me how you did it? Meaning, add another map. The
yeah,
same thing that is already
same
there on the
thing.
canvas will be seen here.
Yeah,
Okay.
we can add different submaps.
Hmm. Hmm.
So now you can see on one submap, you can show the this Black Buck National
I could
Park
have
on one.
changed it to
Yes,
a state, and I could show like India, and
yes. So
maybe
if you
this is
have
the zone
location
part.
map in the one box, you can show the India. Then in another map, you can show Gujarat, and in the third
Hmm.
map, you can show this location. So you can add different layers. And when
Hmm.
you add different layers, you have to use this particular option, which is lock layers. So now,
Yeah.
whatever this layer is there,
Hmm.
consider that that layer is locked. Otherwise, what will
Hmm.
happen? You will changing this layer. So this layer, back layer which you prepared, that will also
Hmm.
automatically change.
Hmm.
So
Hmm.
before doing anything, whatever the layer you have, make sure you have locked that layer. So
Hmm.
now no one should do anything into that. Now if I want to add salt pans there, what I can do is I can just make everything else off and I can just put that salt pan layer on like this.
Okay.
And then I will go there and if I will do refresh, it will show me that salt pan only. So I can zoom it in that map and I can show like this. So you
Hmm.
can show one map, salt map for 2008, one for 2017, and you can put those maps at the below also. Let's say rather than putting over here, you can create a
Hmm.
map below this particular map also.
Hmm.
And then you can export this map. Now, once you want to export, you can see this map which you added at the bottom. It is not in this
Yeah.
page. So if you want to
Correct.
add that in the page only, you can just select this layout option over here. On the right hand side, you have
Hmm.
option layout. So go there, and if you go down, there is a resize layout to content. So it
Hmm.
will make this white paper according to the content which you have. So you can just click on resize layout,
Hmm.
and this is the
Oh.
margin.
Okay. Okay. Hmm.
Okay,
Hmm.
and these are the margin if you want to add. So if you want to add a 5 mm margin on the right hand side, left hand side, top hand side, and bottom, so you can add the margins as well. And then click on resize layout. So now I will remove this simple layer which I added, and then I will click on resize layout. So now I will get my entire screen like this. And once you want to export this map, you can click on this button which is on top, export as image, and then you can save that image as a JPG file or PNG file, whatever you want. So I will save it as a map1, and then it will ask you at what resolution you want to save it. So you can enter the resolution at which you want to save and click on save. And once it is saved, you can see now that layer is saved. And once you go to your data, that folder, figures, then you can see that particular map like this. So that's it. You can prepare different maps similar to this. And if you want to save your QGIS project, then click just Control S and save it as a map 1 or test 1 or whatever you want to write, lab 1, and just save this particular file. So that's all for today's class. What we learned in QGIS today is that we learned that how to add different data, vector data and raster data. In vector, line, point and polygon data, how to change the symbology, color, visualization, labels, and then how to visualize raster data, how to set different color ramps, invert it, how to see minimum, maximum values, and then how to add CSV data sets as well. And then once you have all the data, how to create a story out of the data, how to tell an effective story out of it, and then how to put the data as a map so that policymakers can use it for the decision making purpose. So that's what we learned in QGIS. And in the beginning of this class, we learned about, we just solved some of the questions on LIDAR. So that's what we did in today's class. Is there any doubt for today's class or any comments, suggestions for upcoming class? So should we continue doing this QGIS sessions?
Yeah, I would like it. Advanced QGIS, yes.
So what we planned is like next lectures, I'm going to cover the georeferencing and the digitization part. And if time permits, then how to process those like digitized data. So basically, if you have big data, how to filter out the different data out of it, how to make buffer, how to clip overlay operations, and then how to answer the questions using the vector data only. So in the next lecture, we are going to learn more about vector data. Then after that, we will go to the raster data and we will look more into the raster data. So how to generate the raster data, then how to process the raster data with different operations. And once we are done with this vector and raster data, in the next module, the fourth module on QGIS, we will see how to integrate raster and vector data, and there we will end the QGIS session. And if you're interested in some particular topic, you just write in Q&A session that we want to learn this particular topic. Then I will try to cover that thing in the session.
Okay, that Q&A is not accessible to me. It is not your fault. It is my university. My email ID does not allow that.
Write me on my mail ID as well, which is I will just write it down over here. So you can mail me on this your thing if you want to learn anything else. Anything from you, Ankit?
No, sir. I understand.
Okay, so I mean, I didn't see you more in this doubt session. So can you just introduce briefly about yourself?
Actually, myself, Ankit Ghosh. I am working in an Institute of Forest Productivity, Prachi. My designation is a Junior Project Fellow. My project name is DPR on the Subarnarekhan Damodar throughout the forest intervention.
Okay, so
Yes, sir.
yeah. So if you are interested in particular topic related to your area, just ping me on my mail ID or our Q&A session. We'll try to look into it, some applications as well.
Yes, yes.
Yeah.
There was a situation where people had asked me they wanted to digitize the boundary of some land parcel, and they wanted
Yes.
to do it to the accuracy of like in centimeters, which I could not do in QGIS. So if you could help
So
us in doing that.
yeah. So for that, I mean, it is nothing fault of digitization. We have to do manually.
Hmm.
And this one digitization which we can do is based on AI. So AI will not have that accuracy. We have to do it manually only. So manually, when we are doing digitization, it all depends on the base map which we have. So if we have Google Map, it depends on how much zoom we can do it. If we do it more zoom in, we can do it as a centimeter and mm level accuracy as well.
Acha, got it.
Depends on what base map we have. So we will look into that using Survey of India's topo sheet in the next lab. So that is
Okay.
what we are going to cover in the next lab.
Okay. Yes. Thank you. Thank you.
Okay.
Yes, sir.
Yeah. So with this, we'll end this session. Thank you for joining and good night to all of
Good
you.
night, sir.
Yeah. Bye
Good
bye.
night. Bye, Hiren. Bye.